Today I'm going to do a Unit 3 review video for pre-calc. I'm going to do a partial completion of this. In future videos I'll probably do the whole review, but for today I'm just going to do the ones most relevant to the actual test. So I'm going to start with number 1. It says use the function f of x to do the following: complete the table, sketch the graph, and solve the equation. When we're doing these kinds of problems, it's pretty easy to complete a table. We can just plug in these x values up here to the f of x in the top. You can put it in the calculator if you want to on Desmos. Everyone knows how I love Desmos. 9 times 1/3 to the negative 2 power equals 81. I'll just put 81 in here. Plug in negative 1, I get 27. If I plug in 0, I get 9. If I plug in positive 1, I'm going to get 3. If I plug in positive 2, I'm going to get 1. Sometimes you'll get decimal answers for these numbers. Make sure you plug in, if you read the directions where it says you write as a fraction. A lot of people miss out in the actual test. Really easy to miss, but see if you can put those in fraction form. Make sure you're reading the instructions. Part B says sketch the graph, so we can just put this into Desmos as a graph. You can either copy your points from your table into the graph, or you can copy what you see off Desmos here. So the y-intercept is at 0, 9, so just make sure you have that point, and it's going to look something like this. It doesn't need to be too perfect. As long as it looks like it's about right, it's fine. It's just a sketch. So for part C, solving this equation, there are actually 3 ways we can do this. The first way is we can start with our table at the top and extend it a little bit, see where it goes. If I plugged in 3 for x instead of 2, I get 0.33333, which is 1/3. If I plug in 4, I'm going to get 0.111111, which is 1/9. So that's one way to do that. You'll get x equals 1/9. The other way we can do this is we can take each half of the solve the equation. So this half and this half. Plug those both into Desmos as separate graphs, so y equals both of them. And y equals 1/9. So y equals each half, and I can find the point where they intersect. Right, and I want to look at the x value there, which is x equals 4. Right, if you use that method on a test, make sure you actually write out that you put the graphs into Desmos. Yeah. The third way is we can solve it algebraically. If I divide by 9 on both sides, I'll get 1/3 to the x power equals 1/81. So now I need to figure out x to what power, or 1/3 to what power gives me 1/81, and that will give me x equals 4 again. Yeah, that's generally how you do that one. So I'm going to move on to number 3. So this one's about bank investments. Kaylin invested $700 at an annual interest rate of 4% compounded quarterly. So we have a bunch of letters here. We have A equals P times 1 plus R over N to the N times T power. Find the value of Kaylin's investment after 6 years. How many years would it take to double her investment? And if she compounded continuously instead, how much would it be worth after 10 years? So we need to remember that P equals the principal or the starting value, so P is 700. R is the rate in decimal form, so make sure you do 0.04 instead of 4. N is the number of times per year, so quarterly, we think quarters, which is 4 times per year, so N is 4. And then we also have T, which is time in years. So this time, part A, it's 6 years. So you could set up an equation like A equals 700 times 1 plus 0.04 over 4 times, or to the 4 times 6 power. Right, and then we can take what we have here and put it in a calculator and get an answer in terms of money. For part B, it asks us how many years will it take to double her investment. So we want to figure out how much it takes to get double that $700 she started with. Right, so double of 700 is $1,400, right? So we know that the whole thing has to be worth $1,400. Right, so that's going to equal 700 times 1 plus 0.04 over 4 to the 4 times t power. Now, since we're trying to figure out how many years, t is going to be our variable, so we're going to solve for. You can solve this again in a few different ways. You can do it algebraically, or you can plug in each of the separate halves onto Desmos of their own equation. So y equals 1400. You can also do y equals the right side. Figure out where they intersect, and that's going to be where your answer is. And then part C, if she compounded it continuously instead, so continuously means that n is basically infinity, so we're replacing all the n stuff with the letter e in this equation. E is just a number. So now we have all the same information, except this time t equals 10 years. So I can just plug in all my numbers. A equals 700 e to the 0.04 times 10 power. I just plug it into a calculator, and whatever that equals is my answer. Yeah, that's how we work with these equations. Just make sure you know which letters stand for what. Make sure you have the right numbers for those, and it should be fairly simple after that. But I want to move on to number 4. Okay, so this just says evaluate each logarithm before, so I'm going to show 2 ways to do this. First way is you can look at these numbers, so I'm going to look at part A first. Log base 2 of 64. When you see this, you should think to yourself, okay, this equals 2 to what power gives me 64? So I'm looking for the thing that goes in the box there, right? I know that 2 times 2 is 4. 4 times 2 is 8, so 8 is the third power of 2. 16 would be the fourth power of 2. 32 would be the fifth power of 2. And 64 would be the sixth power of 2. So this whole thing would equal 6. And that's generally what these things are asking you to do. So for part B, you could also do 5 to what power gives me 625. 5 squared is 25 times 5. The third power is 125, and then 125 times 5, which is the fourth power, is 625. If you didn't know these off the top of your head, put them in a calculator, just type out the multiples of 5, and you're good to go. So this is equal to 4. Right? Now, if that method doesn't work for you for whatever reason, you can also straight up put these in a calculator, because Desmos was allowed on this test. So if you go to Functions on the right and go to MISC, and then type in log base A in the bottom left, make sure you type in the base and then what goes on the inside, so 1 over 49, and that'll give you an answer right there of -2. probably the easiest way to do it. And then you could do D the same way and E the same way. Okay, just be careful when you put it in a calculator about what you have in there. Make sure it matches what you have on your test or your review. But I'm going to move on to 5B now. So this one is fairly simple. It says graph each function below and then state the domain of each function. So how we're going to do this is, easiest way is to put it in Desmos. You don't need the g of x or the f of x at all, but you can if you want to. But what is important is you go to functions, MISC, type in natural log, ln, x plus 1, and then whatever you have here is what you're going to put on your graph. Right? So that was something like this. Right? Keep in mind that this graph does not cross x equals -1. It goes like straight down right there. So that's actually important for our domain part of this question. So the domain is all possible x values. This graph never crosses this line, x equals -1, right here. Right? So because of that, x is everything to the right of that, so x would be bigger than -1. It does not equal -1 because it does not cross that line. Right? And that is essentially the first page of the test. I'm going to pause here and then make a separate video for page 2 of the test. So once you finish this video, feel free to move on to that one, and